Okay, a convergent sequence has a unique limit. So first, let's look at the definition of a convergent sequence, which states, for all epsilon greater than 0, there exists a big N in the naturals, such that for all little n greater than or equal to that big N, x little n minus L is less than epsilon. That's in absolute values. So for this proof, we essentially want to show that if the sequence xn from 1 to infinity converges to two limits, let's just call them L1 and L2. Then for the limit to be unique, L1 must equal L2. Okay, so by definition then, taking this definition of a convergent sequence, this is for one limit. So if we're applying it to two limits, we can say for all epsilon greater than 0, there exists n1 in the naturals, such that for all little n greater than or equal to that n1, xn minus L1 is less than epsilon. And similarly, for the second limit, there exists n2 in the naturals, such that for all n greater than or equal to n2, xn minus L2 is less than epsilon. Now for these two conditions to hold, little n greater than or equal to n1 and n2, we can choose our n to be the maximum, of n1 and n2. That way, because it's greater than or equal, this will always hold. Okay, so now to get this condition, L1 is equal to L2. This essentially is the same as saying the absolute value of L1 minus L2 is equal to 0. So let's look at this. L1 minus L2, and now that's equal to the absolute value of L1. Now let's just subtract xn and xn, and then do minus L2. So this is just the same as adding 0, so we're allowed to just do this. And now, by the triangle inequality, we can now split this up and say that L1 minus L2 is less than or equal to L1 minus xn in absolute values plus the absolute value of xn minus L2. Okay? And now because the order of absolute values doesn't matter, we can say that this is less than or equals. Technically this is equals, but this will be less than or equals to xn minus L1 plus xn minus L2. And we can see these are what we have up here in our definition we changed. So therefore, let's change for arbitrary epsilon greater than 0. So this can be any value. This doesn't have to be less than epsilon. We can say xn minus L1 is less than epsilon on 2 instead, and xn minus L2 is less than epsilon on 2 as well, because epsilon can be arbitrarily small. So therefore, that would mean that L1 minus L2 is less than epsilon on 2, just putting this in here because this is less than this, so therefore this will be strictly less than epsilon on 2 plus epsilon on 2, which is epsilon, which gives L1 minus L2 is less than epsilon, which is what we wanted. So now we can choose epsilon small such that L1 minus L2 essentially gets infinitely small and is equal to 0. Splitting the absolute value, this will become L1 is equal to L2, which is what we wanted.